Hi girls, just a quick recap of our lesson the other day. We're going to have a look at some trig identities. So what is a trig identity? Well, an identity, any kind of identity, is simply a statement that is shown to be true for all values of a pronumeral. So we're going to discover some statements that are true for all values in trig identities generally of theta, all values of the angle. So we already know one. We discovered it while we were looking at our unit circle, and that was that tan of theta of any angle is equal to the sine of that angle divided by the cos of that angle. So that's a trigonometric identity, mainly because it involves the trig ratios, and it's true for all values of theta. So I want to just show you one more trig identity, and this is called the Pythagorean trig identity. So the name gives it away, really. It's going to involve Pythagoras, and we're also going to use the unit circle again. So here's our lovely unit circle. It has our radius of 1, it has a point on the circle, and the coordinates of that point are x and y, and we also know that x is equal to cos theta and y is equal to sine theta. So all we're going to do is, using this triangle here, we're going to write down the Pythagorean theorem. So let's do that. Pythagorean theorem, when you learn it in junior school, is just a squared plus b squared equals c squared. And A and B are the shorter sides, and C is the hypotenuse. So let's go back and have a look at our triangle here. The hypotenuse in this case is simply 1 unit long because it's a unit circle. So straight away I can write c squared is equal to 1 squared, which is of course just 1, because 1 squared is 1, so I don't actually need to write that. So let's have a look at the A and the B. Well, the A and the B are going to be equal to the two shorter sides of the triangle, which in this case are x squared and y squared. But I also know that x is the same as cos theta and y is the same as sine theta. So I can write this as well as cos theta squared plus sine theta squared is equal to 1. And that there is a trigonometric identity. So that, in other words, that is true for every value of theta. I don't know why they put the squareds there and not outside, but that's just how you write it. Cos squared theta plus sine squared theta is equal to 1. Let's have a look at some ways that I might use this identity. Okay, here's a question in my nasty handwriting. It's in your book if you can't read it. It says if sine theta is equal to 0.4 and theta is restricted to the range 0 to 90 degrees, so in other words I'm only interested in quadrant 1, find cos theta and tan theta. Alright, well we're going to use this information here. We know what sine theta is, and we can also use the identity that we've just learned. So cos squared theta plus sine squared theta is equal to 1, always. We want to find cos squared theta, or cos theta. So cos squared theta is going to be equal to 1 minus sine squared theta. So cos theta will be equal to the square root of 1 minus sine squared theta. And we know that sine theta is equal to 0.4, so that's going to be equal to the square root of 1 minus 0.4 squared. And I stick that into my calculator and I get a lovely answer. Hang on. Plus or minus 0.917. Okay, now I've been given two answers here, but I remember that I'm only interested in what's happening in quadrant 1. So let's have a look at our unit circle again. All stations to central. So cos is positive here because everything's positive here in quadrant 1. It's negative in quadrant 2, it's negative in quadrant 3, and it's positive in quadrant 4. So I actually don't need to think about the negative value of this answer because it's happening in the two of the quadrants that I'm not interested in. So since 0 is less than theta, which is less than 90, I can say cos of theta is equal to 0.917. Okay, so that's the first part of the question done. What about tan? If I want to find tan of theta, I can use the other identity that we just talked about, which was that tan theta is equal to sine theta over cos theta. So I know sine theta, that was given to me as 0.4 at the beginning of the question, and I've just worked out cos theta, which is 0.917. So using my calculator again, that's going to be equal to 0.436. So that's not too bad, is it? They're actually really useful identities. Let's do one more question and then we'll call it quits. Hang on a minute. Okay, find all possible values of sine theta if cos theta is equal to 0.75. Now this thing here, all possible values, tells me that there is a chance that there could be more than one value of sine theta. So let's have a look. Cos theta equals 0.75, and we know that sine squared theta plus cos squared theta is equal to 1. So sine squared theta equals 1 minus cos squared theta, or in other words, sine theta equals the square root of 1 minus cos squared theta. Okay, so we know cos theta is 0.75, so we can substitute that in. It's equal to 1 minus 0.75 squared, and using my calculator again, I get plus or minus 0.661. So I've got two values for sine theta now. It could be positive 0.661 or it could also be negative 0.661. So looking at my unit circle, you don't have to do this to answer the question. That is the answer to the question, but I'm just going to show you what it means. So if sine theta, if it's in that quadrant, let's call that theta, then sine theta would be 0.661 because all of the trig functions are positive in that quadrant. If it's in that quadrant, then it would be all stations. It would be positive again, 0.661, because sine is positive in that quadrant. And if it happens down in these quadrants here, then it's going to be negative 0.661. So there's two possible values, but there are 4 angles that it could happen. In fact, if we're strictly speaking, there's an infinite number of angles that could take those values because, as I think I've said before, you can just keep going around and around. Your angles go on to infinity. Yeah, look at that in a few lessons. Okay, thanks girls. I want you to go and have a try at exercise 5E, but please do not do questions 9, 10 and 11 because we're going to cover that in the next lesson. Okay, thanks girls. See ya.